Here we begin studying roller coaster physics, and you'll see that we're really going to be looking at how potential energy and kinetic energy kind of transform back and forth. And we can look at this from this roller coaster. If we can imagine a roller coaster traveling up to the highest point A, where it's going to be all potential energy, and then traveling down here, passing through B, down to here, moving back and forth. We're really just looking at its height above the ground. It's going to be all PE, and once it starts moving, that PE is going to be transformed into kinetic energy. And as long as we know points or heights off the ground, we can calculate the amount of PE and KE that it has until down here, point E, is going to be all kinetic energy. That all of the potential energy at A is eventually going to become all kinetic energy at E. So here goes. Solving for, we're going to be looking at potential and kinetic energy. And we're going to be using the idea that potential energy is mass times gravity times height, and kinetic energy is 1/2 mv squared. So here goes, the explanation for the picture. In the picture, you can see that at location A, the roller coaster is all potential energy. And at location E, the roller coaster is all kinetic energy. Therefore, within A through E, one is losing PE and gaining KE. Consider location B. It is 1/4 of the roller coaster's path downward. It has 3/4 potential energy, 3/4 PE, and 1/4 KE. In other words, at A, it's 4/4. It's all potential energy. As it loses 1/4 of its height, it now has 1/4 KE and 3/4 PE. Consider location D to be halfway down the ramp. So it has 1/2 PE and 1/2 KE. And we can use the original values of PE at A to help calculate anything we need using the above values. So we'll get some practice with this. So what is the picture about? As a roller coaster, RC, moves to different heights along the roller coaster track, we can observe how energy is changing forms from potential to kinetic energy. We will assume friction is negligible. The higher the roller coaster is on the track, the greater its potential energy. And as it falls, it will decrease in PE and increase in KE. At all points in the track, the total energy is constant, or the same value. It is only at different forms. It can be potential energy, kinetic energy, or both. So I'll do this little practice problem with you, and the next couple I'll let you solve. Always come back and use this one as a reference. So roller coaster physics. So consider a roller coaster, a car on a roller coaster. The car's mass is 400 kilograms. It starts from rest at point A on the roller coaster itself. Point A is 15 meters above the ground, so I recommend you draw a line and label this 15 meters. Point C is 10 meters above the ground, so label your line 10 meters. Point D is 5 meters above the ground, so label this 5 meters. Point D, so you can assume that friction is negligible and that this illustration is not drawn to scale. So here we can begin solving. So what is the gravitational potential energy at point C? Well, I know that it was at 15 meters and it's now at 10 meters. So if you solve for your total potential energy at A, you could find 2/3 of this, 2/3 of the total energy at A, is going to be the potential energy at point C. Or you could just take mass times gravity, right? It's mass of 400 kilograms, times G of 10 meters per second squared, times 10 meters, and you'll get the same value of 40,000 joules. The kinetic energy at point D and E. So D and E. Notice, at this point it's gone from A, it's gone down 10 meters to reach D, and D is 5 meters above the ground. Where at point E, it's fallen all the way down to 15 meters. So we can solve. So a kinetic energy at point D, it's lost here. It went from 15 meters above the ground, and it's now at 5 meters above the ground. So it lost 10 meters of height. So we know that at 10 meters of height, it's got 40,000 joules of energy, right? So 40,000 joules at D. The kinetic energy was, at this point, is going to be equal to PE at point A. So the PE is mgh. So we can find here that if I solve for the amount of energy at E, I could just say, well, at A, I know that's mass times gravity times height. So 400 kilograms times 10 meters per second squared times 15 meters. That equals 60,000 joules at point A. That's going to equal the same amount of 60,000 joules at point E. Although at E, it's going to be kinetic energy. At A, it's potential energy. So what is the height of point D? Well, according to this, the potential energy at A minus the total kinetic energy at D. So point E at D, so 60,000 minus 40,000 joules equals 20,000 joules. So the potential energy is equal to m times g times h. So if I isolate h, I can solve h is equal to potential energy of 20,000 joules divided by mass times gravity, which is 400 kilograms times 10 meters per second squared. And I can solve that it being 5 meters. But it's also provided in the problem. So we can do it mathematically, or you can just read really well and not have to go through all that. But I do think it's important for you to know how to solve the problems. So last but not least, what is the velocity or the speed at point E right here? So here's how we do this. We know that kinetic energy is 1/2 mv squared. Very important here. So voila, I just placed it in here really quickly. So the velocity at point E. So we know that it originally started off as being all potential energy here. And now it's no longer potential energy, it's in the form of kinetic energy. But it's still this total amount of 60,000 joules. So I can solve this. So if I solve for velocity, I want to isolate V. V is going to equal the square root of 2ke divided by mass. So let's do this. So if I isolate V algebraically, I get V is equal to the square root of 2ke divided by m. So I take the square root of quantity 2 times 60,000 joules. The 2 is simply taken 1/2 side by 2. I have to take both sides by 2. So I'm isolating and solving. 2 times 60,000 joules divided by 400 kilograms tells me that the velocity at E is going to be 17.3 meters per second. It's essentially like it was falling towards Earth from some height. So in other words, we get a velocity of 17.3 meters per second. So what I did was I gave you a basis of making sense of. I'm going to make sure we understand what these ratios or fractions are here, and then I'll let you solve for the next couple problems, and the answer keys are in there. So let's go back and look at these. Let's go back here and look at A. At A, it's all potential energy and 0 kinetic energy. We said it was 15 meters, so we can solve PE is equal to mgh. The total energy in the system is contained right here at A. But at letter B and at letter C, and even though they don't look that great right here, I'm saying that they're the same height, that they're 2/3 potential energy and only 1/3 kinetic energy. So when I go back and look at this, I want to make sure we understand that at B and C, these are the same height. We'll call that 10 meters off the ground. It's still 10 meters above the ground, so it's 2/3 of the potential energy A, and that 1/3 of the height that it's lost is now in the form of kinetic energy. So it's 2/3 PE and 1/3 KE. And at location D, it's 2/3 KE and 1/3 PE. It's still 1/3 of the way off the ground, so it's got 1/3 of its energy in the form of gravitational potential energy. And then at E, it's all KE, 0 PE. And the total energy at all of these letters is all equal to the total energy at A. They're just in different forms. So the height above the ground, at A it was 15 meters, B and C were both 10 meters, D is 5 meters, and E is 0 meters. So I'm going to give you a chance to do some problems. I want to make sure you have a chance to look through this. I want you to go ahead and pause it and solve. I want you to do the work here. And when you're ready, you can find that the answer key at the end of the slideshow, and it might take a little bit of practice. So you have a roller coaster with a mass of 500 kilograms. Point A is 60 meters above the Earth's surface. Points B and C are 45 meters above the surface, and point D is 30 meters above the Earth's surface. So you have information. I recommend you make your drawings and then solve potential energy, kinetic energy, and velocity. So you can get to the end, and you'll find that the answer key, I'll kind of flash these so you can pause them along the way. Here's the answer key for number 1. Here's problem number 2. Same rules apply. You can pause this and kind of go through it. You're solving these problems right here. And in just a second, you'll find that the answer key, if you're looking at the slideshow, just scroll down to the latter slides. Otherwise, I'll flash it for you. Once again, you can pause it where you need to. And then we can get into practice problem 3, roller coaster physics. If you're solving this, here's your roller coaster problem or scenario. And A, B, C, D, E, and F. You got all these letters, and you'll find that you're going to go ahead and solve that. And then here's letter 3. There you go. Best of luck.